Our next speaker is Tiffany Messer. She's an assistant professor and water quality engineer from Biological Systems Engineering at the University of Nebraska.
Good morning. How are you all today? I'll be talking today on treating the water quality cocktail entering recreational and agricultural ponds. And just before we get started, I just really want to thank everyone that's worked on this project. I've had a lot of graduate students and undergraduate students that have worked on this, and none of this would be possible without them, along with funding from the Water for Food Institute, the Biological Systems Engineering Department, and a USGS 104B funding. All right, so we've been talking a lot about the nitrogen issue in Nebraska, throughout the country. I'm not really going to jump too far into that because we've already been talking about it for a while, but the main thing is that the highest nitrate concentrations in ground and surface water can be found in regions of Nebraska. So we have a lot of nitrogen moving through our systems. We're on this crucial surface and groundwater nexus with the Oklahoma aquifer, so we're constantly considering how can we improve the nitrogen issue that we have going on. There's been a lot of changes in surface water. For instance, we see a lot of algal blooms that are happening in our recreational lakes. Not only the recreational lakes, but also in agricultural ponds, which can be critical for livestock. In some states, they're actually finding with these toxic algal blooms, they'll lose an entire herd of cattle. So this is one of those big things that we're considering not only from our livestock, but also from a public health perspective. So another thing that we have going on here in Nebraska is we have a lot of pesticides that are moving through our systems. We need the pesticides, obviously, for agricultural production and success, and also for crop insurance. But the other thing is that they're becoming ubiquitous. And it's not just in ag. We're seeing in 90% of urban streams these pesticides moving as well. So a lot of times we just focus on these ag systems. This is not purely an ag problem. This is a ubiquitous problem in both urban and agricultural landscapes. Oftentimes we're using these on not just your yards, but also on your pets. And your pets sooner or later will end up urinating, and that will also enter into the water system as well. Obviously, golf courses, does anyone have like a very manicured lawn or have neighbors that have that? Typically, they're putting a lot of pesticides. Unlike in ag systems, they're not restricted to how much they can put. So if they have a whole tank of pesticides, they're probably going to throw the whole tank on, because why save it for next year, okay? One of the big concerns we have with these pesticides is looking particularly at this one form called neonicotinoid pesticides, which have been correlated with the bee collapse that we continually see. So it's become a more urgent concern as to how do we save the bees, the monarch butterflies, a lot of our pollinator species that continue to use the pesticides. So we had 3 objectives that are both at field and at the mesocosm scale. Our first objective was to identify trends of common use pesticides in 3 recreational lakes with varying surrounding land uses, meaning some were in ag systems, some were in urban systems, and one actually was in a more herbaceous system. Secondly, create a water quality map across the surface of eastern Nebraska lakes with varying land use. So in these lakes, does water quality change from the inlet to the outlet of the lake? And if so, where are those changes occurring? And then our third objective was, do floating treatment wetlands provide improvement for water quality on water bodies? So one of the biggest challenges we have is we want to treat these systems, but we don't have land to provide to actually put in an adjacent best management practice. So one of the things our team has been looking at is, can we put an in situ practice, meaning can we put a best management practice on the actual water body itself? So the way that a floating treatment wetland works, if you can see right here, this is an example of one out on a lake. Here's another one out in the lake. So they very much blend in with the lake itself. But ultimately, all they are is they're a mat. We're not looking at soil, just purely the mat with some wetlands plants. On the wetland plant roots, a lot of times we'll have these microbes. The microbes are your best friend. They do a lot of the work for the nitrogen removal in these systems. All right, so how do we look at this? So I was describing that we were doing some watershed assessments and looking at these lakes and different types of watersheds. Here's just an image of these. We had Pawnee Lake, we had Holmes Lake, and then we had this red one here at the bottom was Wagon Train. And just to give you a perspective of what the land use was, so Holmes Lake is in a watershed of 83% urban. So we're looking at an urban dominated system. Pawnee Lake is in around 23% cultivated crop and 66% herbaceous. So this is, we considered more of our herbaceous, kind of our control section. And then we had Wagon Train Lake, which was 60% cultivated crops. This is more of our agricultural watershed we were investigating. So we went out and we used Polar organic chemical integrative samplers, we call them POSIS, and ultimately what this does is it gives you an average concentration of your pesticides that are in the water moving through your inlet. And we placed them at each of the inlets of the lakes, and then we also took some groundwater samples at the locations. We also outfitted them with a transducer to determine how much water was moving into the system using water depth and then using the actual survey of the stream to be able to determine what the actual load of pesticides was moving into the system. We then would go to the sites, and then we would take grab samples at these dots throughout the lake to see if maybe the pesticide concentration changed from the inlet to the outlet of each of the lakes. And this one at the top is where the POSIS sampler was located. After this, we would go out with our kayaks, and we had a sensor that we would attach to the kayak that would measure water quality parameters within that first top layer of your water. Why did we just care about the top layer? Well, that's where the floating treatment wetland is going to go. So we don't want to just throw a floating treatment wetland out there and just assume it's going to be in the right spot. So this kind of gave us an idea of where to place the best management practice. We would go out and do 10 predetermined cross sections to create this map using ArcMap and then using a Kriging linear interpolation. And then lastly, we wanted to test at a smaller scale, using pretty much water troughs, would the floating treatment wetland work at removing not just nitrogen and phosphorus, but also pesticides from the water itself? One of the things we don't want to do is go out and spend $10,000 to install one of these systems and it not work at all. So this kind of gave us an idea on a smaller scale before we go out and start implementing and trying these systems out. So some of our results. I'm going to keep the results relatively limited just due to time, but the most important one we got from the lake study was we assessed the average concentration of pesticides in these different systems. So the first bar, this one right here, this black line right here is the chronic invertebrate limits. This is the ecotoxicity limit, where we don't want to see the concentrations being above in these water systems. These are 3 types of neonicotinoid pesticides: clothanidin and imidacloprid. You hear a lot about these typically. They're the most commonly used probably ones I would say in Nebraska. But ultimately with clothanidin, this particular one, we saw a lot of it inside the agricultural system, which is not surprising. It is not on average higher than what would be ecotoxicity, but we do see it within a standard deviation of exceeding it. So that is of a concern. Even more concerning is this one imidacloprid. This is the one that you put on your dog. This is the one that people use a lot when they're in their yards, things like that. And what we saw was that in the ag system, yes, we were exceeding this black line, the ecotoxicity mark, but in the urban system, I mean, this is on a log scale. It was astronomical on average, okay? So we're looking at these urban systems specifically having a lot higher concentrations based on our initial survey of this with these particular type of pesticides. The thiamethoxam, we didn't really see an exceedance for those ecotoxicity, but what's kind of unique about this one is it actually degrades into this one. So it could be there, and it's just ultimately transforming into the clothanidin. So it could be accumulating ultimately. From a field evaluation with the YSI monitoring, so this right here shows temperature differences, dissolved oxygen differences. This one's dissolved oxygen. We have redox. We have temperature, chlorophyll A, so how much algae do you have in your water? And we're able to really see, are there differences at the inlet, base, the outlet, and then we can identify where we should place the floating treatment wetland. Another example of this is at Holmes Lake. So this is nitrate concentrations here. The higher nitrate concentrations that we saw were right after a rainstorm, which is down here. And then compared to, or I'm sorry, right up here is the one that's right after a rainstorm versus before the rainstorm. So we see all this nitrate ultimately moving into the system, and we typically will see it down in this area of the lake, which then can give us guidance as to where we should put the floating treatment wetland if we wanted to utilize that as a best management practice. You probably don't need it down here. It's entering through here and then moving this way, so you can maybe catch it right as it's moving into the system. So then we asked the question, well, would the floating treatment wetland work if we actually were to implement it? So we did the Mesocosm studies, and ultimately what we found in these studies is that we have a nitrogen removal of 100% within 7 days if you were to put 10 milligrams per liter into these systems. That is with a 60% coverage. Now, obviously, you're not going to have a 60% coverage in your lake. You might have more of a 1 to 5% coverage with the floating treatment wetland. But if you're capturing it, especially at the beginning of the spring, it can provide some definite benefits And if you've just dredged your lake to kind of remove some of that nitrogen and phosphorus, it would be a good way to kind of keep your system healthy if the watershed's not really changing a lot of the parameters within it. The other thing we looked at was pesticides. So for imidacloprid, we got around a 70% removal of imidacloprid and 57% removal of thiamethoxam in a system with the floating treatment wetland compared to the one that did not have one. The one that did not have one had about a 30% removal, and that probably was from photodegradation. So UV actually can degrade some of these pesticides. So in conclusion, pesticide accumulation and concentrations were highest in the urban lake compared to the predominantly agricultural and herbaceous systems. The lake mapping tool provides a new insight on how we can assess lakes for identifying where to put these BMPs, either in situ or even adjacent to the lake itself. Floating treatment wetlands appear to be a promising and innovative solution for how to treat these waters. Some of our future work is we're going to be evaluating floating treatment wetlands for also antibiotic and nitrification mixtures. So we're looking more at that cocktail again. How does it look not just for one pesticide or one antibiotic, but for a mixture of that with maybe antibiotics and pesticides and the nitrate coming in. Assess seasonal changes on how water quality across recreational lakes. So is there seasonal changes of where you should put the floating treatment wetland? One of the great things about them is they're not stuck where you put them. You can move them. So if it's a seasonal change, you can move them around. Determine feasibility for the floating treatment wetlands during Nebraska winter. So these have been used primarily in the southeast, although there are a few in Minnesota. But I want to know what happens when the snow comes to Nebraska, and is it going to sink the wetlands? So one of the things we're doing this summer, or this fall and winter, is at the Sunken Gardens. If you're there in one of the koi ponds, we have one of our little demos there, and we're going to be assessing will it sink or will it float all winter. So that'll kind of give us an idea for maintenance and how much that's going to cost. So references, and then I think we're going to wait for questions till later. So thank you all for your attention.